In this one, we're going to learn a little about Nmap and use it to scan for open ports, and then we're going to use Wireshark to look at UDP DNS captures. So both of them will be done in our CyberOps, or both parts are going to be done in our CyberOps workstation. So go ahead and log into your CyberOps workstation as analyst. When you get to the desktop, we're going to open the terminal window. Let's go ahead and click on the terminal icon. I just moved it a little bit, sorry. And then the first part is to learn what Nmap is. So if we use the man pages, we'll type man Nmap to learn a little bit more about Nmap. So what is Nmap? You can kind of read here. It's Network Mapper. It's a tool used for network exploration and oftentimes security auditing. So it can scan for open or for hosts and then services that are open on those hosts, like we're going to do here. You can make your way through the man pages by using the arrows or a space bar if you want to go a whole page at a time, or if you want to search for a particular term, you use the slash or a question mark and then follow that by the term that you want to search for. Here we're going to search for example, so we'll type slash example and hit enter, and it'll find all occurrences of the word example. You can hit N for next, and it'll go to the next occurrence of that word. So in example 1 here, it shows you kind of a usage for Nmap. So they have nmap-a-t4 scanme.org. That's the Nmap command that's being used there for that example. And so then what does the -a do here? So we need to know we need to figure out what do these options do in Nmap, because we're going to use them in a minute here. And if we look right above this example command, it actually tells us. So -a, so the only arguments used are -a and -t4. -a is to enable the operating system and version detection. Script scanning and traceroute. -t4 is for faster execution. And then the host name was the part we used after. So A is to enable OS detection, version detection, script scanning, and traceroute. And then T4 is used for faster execution. So let's go ahead and start scanning for open ports. We're going to scan our local host, which is just this computer here. So type Q. You can sit and scroll through. Sorry, I could have done that as examples. Scroll through the man pages, learn more about Nmap, learn more about the options. We're going to go ahead and scan our local host. We're going to use Nmap to find out which services are open on our host. So we'll do Nmap space -A space T4 space localhost. And it'll start scanning. It'll take just a little bit. And we should be able to see which ports or services are open as soon as it gets done here. There we go. All right, so we want to look and see which ones are open. We have FTP, port 21, FTP is open. Port 22, you see the open. Port 22, SSH is open. The actual application for this is OpenSSH. For the FTP, it's VSFTPD. And what else do we got open? Telnet. And the application is OpenWall. And we've got port 80 or HTTP open. And the application is NGINX. The operating system being used here is Linux, OS. All right, so now we've used Nmap to see what's open on our host. Let's use Nmap to scan our network. Now this is a contained network, right? Actually, all of these VMs are on servers for you guys. So everything that's served up to you guys is on its own separate topology. So if you're scanning your work network, don't get yourself in any trouble. You're scanning at the school or whatever. But this is all contained, so nothing to worry about here. First thing we want to do is, before we begin, we're going to do an ifconfig and see what our IP address is. And our IP address is 192.168.0.11. And we use a 24-bit subnet mask. So that means that the network being used is 192.168.0. If we AND the subnet mask with the address, that's what we should get. We'll scan our network using Nmap. So we've Nmap -A-T4 space, and we want to scan the network, so we use the network address of 192.168.0.0 and our 24-bit subnet mask, so /24, and hit enter. This could take a bit, so I may pause this in the middle just so you don't have to watch it sit here. That might take a few minutes, 4, 5, 6 minutes, something like that. Luckily, it's a pretty contained network, but it's got to go through all of these and find results, find out what's open or available, what it gets a response from. All right, so we got our responses. Now we need to look through and see what's available. And what did it find? It found 192.168.0.10 on the network, and it found its different open ports. Let's see, we found .11. And what's open on .11, which we already knew because we scanned ourselves, right? So it looks like it only found 2 hosts in this network. So it only found 2 hosts in this network range, in the 192.168.0.0 network. And so we found 192.168.0.10 and 0.11. Now let's go ahead and we're going to scan a remote server. So we're going to scan the 209.165.200.235 server. And that on our network, I think, is metasploitable. Let's look. So yeah, 209.165.200.235 is this machine right here. So we're going to scan this machine. Bring my CyberOps workstation back up. And let's use our Nmap command. So Nmap -A-T4 space and the address, so 209.165.200.235. Whoop, 235. And we'll let that scan. If that starts taking too long, I'll pause again and just jump back to it so you don't have to. You know what? I don't know why I keep letting this window be so small. There's so much more room here. Oh. And we'll wait to get our results. Now, when you're doing this on your own, this might take a bit. I'm going to pause and just come back to it so you don't have to sit and watch it. All right, so we got our results. It was scanned in 196.06 seconds. The host is up, and if you read through it, it just shows the various ports that are open. And this is what's open on that metasploitable host that we scanned. And when you answer the questions, you can just list a few of these. There are quite a few that are open. There are 977 closed ports. If there's filtered ports, they'll show up in here as well. The operating system is Linux. So this is just some of all these different ports then you can actually use with another program. So now a lot of times Nmap's going to be used, right, to scan for ports as part of your reconnaissance. So now I know what's open on this host. I can try to compromise what's open, the different ports that are open, which I think we actually do in a later lab. So that's kind of Nmap. That's just touching on it. It can do some other things, and this is what it's mainly used for. Security auditing, see what's open on your network, see what's available, reconnaissance, things like that. Now we got to move on to using Wireshark to look at UDP and DNS captures. Our CyberOps workstation. So I logged into my CyberOps workstation and open a terminal. So the first thing we want to do is find out information about our workstation. So we want to get the IP address, the MAC address, the default gateway, and the DNS or name server that it uses. So we'll start, open the terminal, enter ifconfig to get our IP address and MAC address. The IP address 192.168.0.11, so write that down. And your MAC address 08002723B231. You can probably get away with writing down B231. And again, don't forget yours is different. Yours may be different. So we've got our IP address and MAC address. Now we want to get our DNS information, or what DNS server we're using. So we'll use the cat command to do that. Cat space /etc/resolve without an E .conf, and hit enter. Now our DNS server is 209, or what it's using to resolve is 209.165.200.235. And then we want to find out what our default gateway is. So we use the netstat command for that, netstat-r. And our default gateway is 192.168.0.1. Next, we're going to get into analyzing the captured DNS packets. So we want to open up Wireshark. Sudo space Wireshark -GTK and hit enter. Put in the CyberOps password and click OK. Now we've already got the CyberOps workstation already has a DNS capture saved on here, so we just want to open that up. Go to File, Open. Oh, let's go back. I'm going to go back one just in case it didn't start. A lot of times you'll start in your home directory. This actually was already in the PCAST file, but let's assume we're in our home directory. We'll close this up. We'll start again. File, Open. Oh, sure. If you start in Analyst, which is more likely where you'll start, depending on how you start the lab, go to Lab Support Files, go to PCAPS, double-click that, and then click your DNS traffic PCAP, click Open. Now we want to filter on DNS packets, so we'll type DNS in our filter and click Apply. The first packet we want to examine is actually the very first one. In this case, you're trying to find the one with your standard query, a/google.com. So now we're just going to go ahead and examine that packet. Click on it. If we look down on the details page for this particular packet, we see that it's 74 bytes on the wire. That's the number of bytes it took to send a DNS query to the name server requesting the address of google.com. And if we look at the Ethernet 2, we can just look at this line, or we can open it up. The source MAC address is B231. Okay, well, it's longer than that. The last four digits are B2:31. The destination is 0158. Is the source MAC address the same as the recorded? Yes. This B231 is the same MAC address that I recorded for my workstation, or for the CyberOps workstation, which it should be, right? Because it was the CyberOps workstation that is trying to go to Google. Therefore, that's the device making the DNS query. If we go down to the Internet Protocol, we find our source and destination for the IP address source and destination. The source is our CyberOps workstation. The destination is the DNS server. Is actually Google's 8.8.8.8 in this case. Now we click the arrow next to user datagram protocol. So DNS uses UDP for its queries. It has less overhead, doesn't need to use TCP. So we open up our UDP header. It only has 4 fields. We have our source port, our destination port, our length, and our checksum. So we want to read through that and just record the results, record what you see. What's the source port? In this case, it's 44.188. Destination port is 53, which is our well-known DNS port. The length is 40. Source IP is 192.168.0.11. Our destination is 8.8.8.8. So our source IP address is the same as this workstation, a CyberOps workstation. Our destination address is the 8 address. It's not going to be the same as our default gateway in this case. So now let's go ahead and look at the response packet. That should be this one. This one right here will be our response packet, should be. So what we should see is things are flopped, right? So originally our destination was the 8.8.8.8. Now it's our source, and our destination is now, because it's responding to. So originally our workstation sends out the DNS query, the DNS response then comes back from the DNS server to our workstation. So our IP addresses and MAC addresses should be flipped in this point. And if we go into our Ethernet 2, now the destination, our destination is now what used to be our source. The destination is now our workstation's MAC address, the B231. And again, looking at our IP address, our source is now the 888, and our destination is the 192.168.0.11, so they've just flopped in this case, which makes sense. We sent out the query, we get a response. It's just the way it comes. The source and destination are going to be flipped because the source is now what I originally had sent, who I had originally sent it to. Whoop. Lost my viewer. All right, I'm going to pause and refresh it for you so you don't have to watch that. All right, so if we look a little more at this, we also see that our ports are swapped now. So now our source port is the DNS, the well-known DNS port of 53. And the destination port is the 440 or the 44.188, the port that, you know, VMware just picks, it just chose an unused port in the first request, and then the response, and then it stays open and listening for the response on that port number as well. We close this up. We can open up the DNS response, and we can go down to answers, and we can see that we got google.com, type A, and the address. So we can get all kinds of information about the packet. And then what are the benefits of using UDP instead of TCP as a transport protocol for DNS? The session's going to be quicker. The response is going to be quicker because we don't have to do the 3-way handshake and we have less overhead. Those are some thoughts. There are a few other things you can add in there. But that's it for this one. We have looked at a DNS query, a request, and a DNS response. And it's amazing, too, if you think about how quickly that happens. But that is happening. If you were to sniff your own network, you'd see that that's happening.